All right. Welcome back. The cat just unplugged the computer, but we're back. Actually, it wasn't unplugged. She hit the reset button. The power button I have blocked, but the reset button I have not blocked. But anyway, we're back. So we have these special triangles. We need to solve the triangle. So first off, start with what's easy. All of the angles of a triangle add up to 180 degrees or pi radians. So how many radians are left? Well, you don't even have to really answer this question, right? You already know if one of them is pi over 6, the other one has to be pi over 3. But let's say that you didn't, right? So pi total minus pi over 2 minus pi over 6, and you'll get that pi over 3 is left over. A couple different ways of finding out that pi over 3 is the remaining angle. And then again, we just use this triangle. The hypotenuse is always going to be double the length of the short side. Hypotenuse will be 6. Which is close to what Cooldown had in the chat. The long side is going to be the square root of 3 times the short side, so 3 times the square root of 3. All right. So here we go. That's the answer. So let's do another one. Okay, and we're going to make this next one a little weirder. All right. Because now the triangle has fallen over. The triangle has fallen over, and that can a lot of times make things a little more confusing. But it's the same idea. So here I'm going to give you a pi over 3 angle, and I'll give you the long side is 8 times the square root of 3. So almost always when you're solving a triangle, almost always, the best thing to do is to start by filling in the angles. Angles are usually easier than sides. So again, you know, just like before, okay, if one side is pi over 3, the other one has to be pi over 6. Or again, the long way would be if one side's pi over 3, the other one is pi total minus pi over 2, that's the 90 degrees, minus pi over 3, and then you get some common denominators. You're going to write this as 6 pi over 6. You're going to write this as 3 pi over 6. 6 minus 3 minus 1. Sorry. And this is 2 pi over 6. Great. 6 minus 3 minus 2 is going to be 1. We have 1 pi over 6. Pi over 6 is the remaining angle. Okay? That's how you would do it. Then again, so this is the long side. Remember, the long side is always the one opposite pi over 3. Sometimes the figures are not always going to be drawn perfectly. So the short side, well, if the long side is always the square root of 3 times the short side, the short side will be the long side divided by the square root of 3. So if we divide the long side by the square root of 3, they cancel, and we're just left with 8 remaining for the short side. And yes, the hypotenuse is 16. Very good in chat. All right, let's do one last one. All right, you may have been feeling left out if you are a 45 45 90 triangle, but don't worry, we have an example for you too. So let's say here we get some audience participation on this one. Somebody tell me a number. Somebody give me a number between 0 and 100. Preferably an integer, but it doesn't have to be an integer. 1, all right, something other than 1. 73, I can do that. All right, so we have a side of 73. Oh, I already filled in. If one side is pi over 4, the other one's going to be pi over 4. I gave you a freebie on that angle. All right, so if this side is 73 degrees, so this is the problem. I have to make sure, because I'm filling in the problem as I'm writing it. This is the problem. And then, of course, yes, the other side is also going to be 73 units. The two sides are, it's an isosceles triangle. They're always the same. And then what is the hypotenuse? The hypotenuse is going to be this times the square root of 2. So you have 73 times, oh, I don't have a lot of room. 73 times the square root of 2 is hypotenuse. Yes, very good. Very good, Cooldown. All right. So that's the answer. That's how you solve these triangles. All right. So let's now move on from something that's sort of mildly academic to something that is very academic. But the next example is going to be very, very useful. The next example is going to be probably one of the most important skills that you can have in this entire class. All right. So it's very, very, very important. And here's the catch, is that this next example is trivial if you have a calculator. And again, you will have access to a calculator for all your quizzes, all your homeworks, all your exams. You will have access to a calculator. However, if you can solve example 4 without a calculator, you will have so much extra understanding, and that understanding is what's going to be useful for the future of this class. So I highly recommend that when you're doing the homework problems similar to example 4, do it without a calculator, because that will really, really help you have an understanding that will let you essentially do the future chapters more easily. So I'm not going to force you to not use a calculator here, but I would highly recommend it. Because here's what we're doing. Use special triangles to find the 6 trig function values for the following angles. So again, you can just type, well, what's sine of pi over 6? What's cosine of pi over 6? What's tangent? You can just type all that into your calculator. But you will benefit later on in the semester if you do not. So here we go. Pi over 3. And part B is going to be pi over 4. So the thing for this is for pi over 3, you can use any pi over 3 triangle that we have. So up here, for example, we have a pi over 3 triangle right here. You could find sine of pi over 3 is 3 root 3 over 6. That's fine. All right. And then you simplify it, and you're going to get square root of 3 over 2. You could use this one. Sine of pi over 3 is opposite over hypotenuse. 8 root 3 over 16. It cancels, and you get the square root of 3 over 2. More desirable probably is to use the very standard one I gave you. Sine of pi over 3 is the square root of 3 divided by 2. Yes, you'll be doing cosecants and cotangents here as well. I want all 6 of the normal ones. No inverse functions yet. So then, we use these triangles, which I will give to you on quizzes and exams. I will give you these special triangles, okay? So, sine, oh, this is unfortunate. It does not fit on my page. Ooh, what I can do is use, never mind. No, I won't. It's fine. So, if you have no idea how to do this problem, just start by writing things down. Sine of pi over 3 equals something. Cosine of pi over 3 equals something. Tangent of pi over 3 equals something. And then we list the reciprocal functions, okay? So cosecant of pi over 3 is something. Secant of pi over 3 is something. Cotangent of pi over 3 is something. So we've already done a lot of, oh, you guys can't see that. We've already done a lot of writing, but we haven't done any math yet. And that's an important tip for any quiz or exam taking in this class, or really probably most classes. If you don't know how to do the problem, write down what you do know. At least write down what I'm asking for. If you show that you understand what I'm asking for, there's a good chance that you're going to get partial credit right there, even if you know none of these values. And again, for this one, you can use your calculator as long as your calculator is set to a form that will give you exact answers. I will be requiring exact answers. All right, so then again, you just look at your special triangle. Say, okay, pi over 3 is right here. Sine of pi over 3 is opposite over hypotenuse. Okay, so opposite, we have square root of 3 divided by 2. And that's our value for sine. Square root of 3 over 2. That's another good point as well in the chat, is that sometimes just writing down what you do know gets your brain going, gets you out of that frozen phase, and a lot of times it can help you remember what you might not think you know, but you might actually know. It also can be helpful for writing. Quick tangent, but if you're writing a story, or if you're writing an essay or something, and you're just blanking out blank sheet of paper, sometimes just writing stuff, even if it's garbage, you can erase it later. Just start writing things down can also help. Math is similar. Okay, so again, now cosine of pi over 3 is the adjacent, which is 1, divided by the hypotenuse, which is 2. We got 1/2 right here for cosine. Tangent of pi over 3, we do the same thing. We go to our triangle. Tangent is opposite over adjacent. Remember, SOHCAHTOA. Opposite over adjacent, that's the square root of 3. And now we've done all of the hard work. Okay? All the hard work has been done because all that's left is the reciprocal functions. And the reciprocal functions, as their name implies, are just reciprocals. Okay? So cosecant is 1 over sine. It's the reciprocal function of sine, so cosecant of pi over 3 will be the reciprocal of this, which is just 2 divided by the square root of 3. And this prompts a very natural question. Do you need to rationalize the denominator? Okay? And honestly, I don't care. If you want to rationalize the denominator, go for it. If you want to leave it like that, go for it. I'm going to leave it like that. I don't care about rational denominators almost ever. Later on, when we're simplifying like trig identities and stuff, we'll have to rationalize denominators in order to simplify some things. But as a rule, no. Feel free to be as irrational as you want. Okay? So again, secant, reciprocal of 2 1/2. Sorry, jumping the gun here. Reciprocal of 1/2 is 2/1. 2 divided by 1. We don't need to write the 1 in the denominator. We just write 2. Reciprocal of the square root of 3 is 1 divided by the square root of 3. Or if you wanted, you could write this as root 3 over 3. All right? And that's all it is. Look at the special triangle to see what sine, cosine, and tangent of the angle are. And then for the reciprocal functions, just take the reciprocal. All right? So real quick, let's go through the same thing for pi over 4. Pi over 4, I'll make one of my viewers happy. The triangle for pi over 4 is whatever the sides are, the hypotenuse is the square root of 2 times that. Okay? So again, we just start writing everything down. We need pi over 4. We need sine of pi over 4. We need cosine of pi over 4. We need tangent of pi over 4, and then we need all the reciprocal functions of these. So cosecant of pi over 4, secant of pi over 4, cotangent of pi over 4. And so pi over 4 is this one, and pi over 4 is also this one. You can use either angle you want. They're the same angle. They'll have the same trig function values. So sine of pi over 4 is the opposite divided by the hypotenuse. 1 over the square root of 2. Cosine, adjacent over hypotenuse, 1 over the square root of 2. Tangent, opposite over adjacent, 1 divided by 1. It's just positive 1. Good. And now we just flip them all. The square root of 2 divided by 1. The square root of 2 divided by 1. And 1 divided by 1. Very nice. There you go here. And again, I've been saying it out loud, but if you're curious, I do want to write it again. If you forget what sine, cosine, and tangent are, we have this little guy called SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? Very good. Very good in the chat. I like that. So, and that's basically what we have here. That's the answer to example 4. This is extremely important, okay? So important. Watch this. I'm uploading the notes as well as the videos. This way, if someone doesn't catch the video, they can see that I'm really drawing a lot of arrows and a lot of capital letters to see that this is an important example, right? So you can do the same thing on your own. Anyway, that's example 4. So we're going to get into a couple definitions and then one more example, and we're going to be done for the day. Okay, and we'll finish the section tomorrow. So let's talk a bit about cofunctions and complements. And no, I'm not talking about saying that you look good in that shirt. These are the other kinds of complements. Something that complements, like complementary colors, for example. Well, not entirely like that, but that's the same, that's the right spelling of complement at the very least. So let's look at a triangle. A triangle just like any other triangle. So this triangle doesn't have numbers. Let's call the horizontal component x, the vertical component y, and the hypotenuse r. We'll get into why we're calling it that in a couple sections, but this is a little foreshadowing for all of you guys. So, and let's call this angle theta, and this angle phi. Again, as a reminder, phi is this Greek letter. It looks kind of like that. All right. And I'm just gonna comment on some observations. Okay? One observation, right, is that the sine of theta is the opposite over the hypotenuse. It's y divided by r. The cosine of phi, well, that's the adjacent for phi, which is y divided by the hypotenuse, which is r, y over r. Interesting. Sine, cosine. They're almost the same word. One of them has a co in front of it. Let's look at just some other random observation. Okay? Let's see, what are some other functions? Let's talk about secant. Yeah, let's talk about secant. So secant of theta is 1 over cosine. So it's the reciprocal of x over r. It's going to be r over x. What happens if we add a co in front of this and look at the other angle? Well, that's not how you spell it. Cosecant of phi. Oh, dear. Sorry. This was supposed to be a phi. Yes. Anyway, sine theta, cosine phi. Secant theta, cosecant phi. Well, that's going to be 1 over sine of phi. Sine of phi is x over r. You take the reciprocal. That's r over x. Interesting. Okay. So the cofunction of the other angle is the same as the original function value. That is not a coincidence either. All right, and this has a lot of interesting theories, and this is where we're going to start talking about our first set of identities. Okay, so first some definitions though. We're going to define the relationship between phi and theta. So if theta plus phi equals 90 degrees, or pi over 2, we say they are complementary angles. All right. Another way of thinking about this is phi and theta are just the two angles in a right triangle that are not the 90 degrees. Okay. Another way you may want to think about this is you may wish to think of phi. If we solve for phi, right, the way we solve for phi is subtract both sides by theta. You get pi over 2 minus theta. That's another way of thinking about a complementary angle. But the important thing is realizing that complementary angles are just the two angles in a right triangle. They add up to 90 degrees, or one of them is 90 degrees minus the other, equivalent ways of thinking about them. So that's the definition of a complementary angle. So furthermore, we've got some properties of complementary angles that we have implied, not proven, and we're not going to prove. Right? The sine of one angle is the same as the cosine of its complement. The secant of one angle is the same as the cosecant of the other. And you might be able to guess, but the tangent of one angle is the same as the cotangent of the other. Okay? So these are what's known as the cofunction identities for potentially obvious naming regions. And essentially, it's just, we can write these all down if you want, and I'll write them down quickly so they're in your notes. But really, the cofunction identities can be summed up in one sentence. The trig function of an angle is the same as the cofunction of its complement. Okay, so for example, sine of theta is equal to cosine of its complement. And you could write phi right here if you wanted. But let's write phi in terms of theta. Phi is pi over 2 minus theta. Right? And if the sine of one angle is the cosine of the other, it follows that the reverse is true, right? So cosine of theta is also sine of pi over 2 minus phi. Sine of one angle, cosine of the complement. And we do this for every single pair. Okay, so similarly, right, the secant of one angle is going to be the cosecant of its complement. And the cosecant of an angle is going to be the secant of its complement. Also, I don't think I've mentioned this, but you do not have to memorize the identities. You will have to use them mostly in chapter 9, not so much right now. We're just kind of introducing some of them where they naturally appear. You do not have to memorize them. I will give them to you for quizzes and exams, okay? You just have to be able to understand them and see how they're used. All right, and finally, the tangent of one angle is the cotangent of its complement. And the cotangent of its angle is the tangent of its complement. All right, so there's 6 of them, but really it's just you take a trig function value of an angle. That's the cofunction trig value of its complement. So again, all this little thing means is the complement. And this is just the cofunction. And the cofunction, if you haven't connected the dots, is just the function with the word co in front of it, right? Sine, cosine. Secant, cosecant. Tangent, cotangent. That's all a cofunction is, okay? So let's use this a little bit with some hard, not hard as in difficult, but hard as in like physical or something. I don't know. Anyway, we're not doing applications yet. Don't worry. I don't even know what I'm talking about. Let's do example 5, okay? So if the sine of theta equals 5/12, find the following. And there's a couple ways of solving these. But first, let's look at cosine of pi over 2 minus theta. And I'm going to talk about 2 ways to solve this problem, and we're going to solve part B and C in only one way. But the most important thing I really want to stress here, and this is going to be much more of a problem later on if you misunderstand it, but the most important thing right here is sine of theta is this ratio. Sines, cosines, tangents, all these trig functions are ratios of sides for a given angle. This doesn't tell us what theta is. Later on, we'll be able to use it to find out what theta. But do not say, oh, theta is 5/12, plug in 5/12 in for theta. No. Theta is not 5/12. Who knows what theta is? Theta is going to be some garbage number. It's irrational, I think. All we know is what sine is. We do not know what theta is right now. Okay, so notice here, this looks a little similar to something we've seen before. In fact, we just talked about some cofunction identities where we said the cosine of pi over 2 minus theta, oh, look at that, that's exactly what we have here. We said the cosine of pi over 2 minus theta is just equal to sine of theta. So, if they're equal, we replace cosine of pi over 2 minus theta with sine of theta. This looks much nicer all of a sudden. Also, we know we were told that the sine of theta is 5/12. So if they are equal, we can replace them. Sine of theta is 5/12. Replace the sine of theta with a 5/12. The cosine of pi over 2 minus theta is equal to 5/12. There you go. That is one way that you can use the cofunction identities. Now let's take this a step further. This A, B, and C, usually A, B, and C are 3 different things. This one is just 3 different steps to the same problem. Oh, I said I was going to show you another way to do this. The other way to do this would be to draw a triangle. If you recognized, oh, this is just a complement of theta, then really what we have is a triangle right here. I don't know, figure not drawn to scale. I don't know what the triangle looks like. But if we have some angle theta here, really we're looking at its complement, let's call it phi over here, and we're asked to find the cosine of the complement. Well, if we know that sine of theta is 5/12, that means the opposite side and the hypotenuse has a ratio of 5/12. And again, we don't know whether this is 5. We don't know whether this is 12. It could be 10 and 24. That still has a sine of 5/12. We don't know how big the triangle is, but it doesn't matter for trig. We're only trying to find things about the angles. So we can just pretend that the triangle is 5/12. But it could be any scaling of these. Okay? And then you could say, okay, well, what is the cosine of its complement? The complement in this case is phi. Oh, adjacent over hypotenuse, 5/12. That's another way of solving it, is drawing a picture. And just like I mentioned that if you don't know what you're doing, to at least write down what I'm asking, so maybe you get some partial credits. Also, if you don't know what you're doing, drawing a picture can be very helpful as well. Okay. Anyway, let's move on. Cosecant of theta. What is cosecant of theta? And again, let's forget about this picture for now. We'll put this in giant parentheses. You could look at that, but we're not going to. Well, this is a silly problem right here because we already know the answer. Cosecant is the reciprocal function of sine. We already found out what sine was. So cosecant is just going to be the reciprocal. Sine of theta is 5/12. Cosecant is going to be 12/5. There we go. Well, that one was easy. I know you're probably disappointed. We'll go on to part C. So in part C, find the secant, okay, of pi over 2 minus theta. All right, things are getting a little bit more interesting now. All right. Well, whenever you see pi over 2 minus theta, I want you to realize two things. Pi over 2 minus theta, whenever you see this right here, think complement. Okay? Think complement and cofunctions. We're going to look at our identities and say, okay, what do we know about secant of pi over 2 minus theta? And we go, secant, where is it? Okay, here it is. Secant of pi over 2 minus theta is cosecant of theta. Not C. Do we know anything about cosecant of theta? Why, yes, we do. Cosecant of theta, we just said in part B, is 12/5. Boom. There we go. We got our answer. All right. So there we go. That's cofunctions and complements. Tomorrow, we are going to continue by finishing off on cofunctions and complements. We got one more example for you. Or we could do it right now. I don't have room. Let's do it tomorrow. Okay, I'll hold myself back. Tomorrow, we'll do it tomorrow. We're going to finish the section tomorrow and then probably start, we might start 7.3 tomorrow. We might start it next week as well. We'll see. Again, your first quiz is due tomorrow at 8 o'clock. Your first homework is due tomorrow at 8 o'clock. And then tomorrow as well, your next homework assignment and next quiz will be assigned. You'll be able to access those in the week 2 module, okay? If you can't find anything, if you're ever uncertain on when something is due, if you're curious or just want to know what my favorite color is, feel free to send me an email, all right? Thank you for watching.